My name is Moritz Lehmann. I'm a research fellow at the University of Waikato, and I lead critical step 1.2.2 on the ground truthing of new remote sensing technologies for the water quality measurement in New Zealand lakes. I work on this project together with my postdoc, Wen. The objective of this critical step is to improve the determination of lake water quality by satellites so that remote sensing can eventually become a routine monitoring tool at all scales in New Zealand, from individual lakes to nationwide. And our approach is divided into four major activities. First, we are obtaining all available nationwide satellite data. For example, we have just downloaded 18 years of Landsat imagery, and we're also looking at other satellites such as the Sentinel series satellites. We are collecting field samples from lakes in various regions for the ground truthing and algorithm development. We're looking at other sources of data, for example, MFE water quality datasets and datasets held by regional councils, to find in situ data that have been collected concurrently with satellite observations. And finally, we'll be using the information from the previous three activities to test existing algorithms and develop new ones. We are now halfway through the 3 years that we have for this critical step, and we've been very busy. In February this year, we submitted a report to the Waikato Regional Council, our action partner and co-funder for this critical step, on the feasibility of using remote sensing for water quality monitoring in the Waikato region. We have also analyzed the Landsat lake water color dataset and produced a poster that we presented at the New Zealand Freshwater Sciences Conference and a talk at the Oslo Aquatic Sciences Conference in February 2017. A similar poster was also shown at the International Ocean Color Sciences meeting in May 2017. Ongoing activities are field campaigns to collect in situ data from lakes in the Waikato and Bay of Plenty regions, and correspondingly those two regional councils are our action partners on this, and we're reaching out currently to Horizons and Southland regional councils to do the same in those regions. So plans for the remainder of the project include enhancing our liaison with other regional councils and action partners to extend bio-optical or in situ sampling in other regions of New Zealand. We'll be downloading more satellite data from other sensors and expanding our analysis that we've started so far. And then we'll be matching up the in situ data with the remote sensing data to then do the algorithm testing and development phase of this project. Currently, we're working on the completion of 2 manuscripts, which are falling out of the posters we presented earlier. This is the New Zealand-wide visibility and lake color analysis, and also a trend analysis of how lake color changes over the 18 years of the Landsat dataset. We're anticipating at least one other publication on the national application of water quality assessment using remote sensing. Now I would like to briefly show some of our initial results to illustrate what we've been up to. We downloaded the entire archive of Landsat satellite imagery for New Zealand. This dataset begins in 1999, so we have over 18 years of data. However, the following analyses use only data from the latest satellite in the Landsat series, which is Landsat 8, and that began taking images in 2013. We extracted data for each lake from a 3x3 pixel area near the middle of the lake and ended up with about 64,000 data points from our 3,820 lakes over 4 years, which we used for further analysis. To To get an idea of how feasible it is to use remote sensing data for lake water quality monitoring, we asked two questions. First, how often are New Zealand's lakes observed from space? And second, how different are these lakes in terms of their optical characteristics? The first question is related to how efficient a satellite-based monitoring program could be, and the second question provides insights into how hard it might be to transform satellite data into attributes related to water quality. And here are the results. The first dataset shows the average annual frequency of satellite observations, a quantity that we may call visibility. In this map, each New Zealand lake is represented by a single dot. The color of the dot indicates how many times the lake has been observed by Landsat 8 on average per year. The frequency of observation ranges from 1 to 16 per year, and there's some interesting regional patterns. But first, the red rectangles on these maps are the segments of the ground paths of the Landsat sensor, and we can see that these segments overlap in some areas. So some lakes are observed more frequently than others, simply because they're covered in two ground paths. The remainder of the variability in visibility is related to cloud cover, because satellites can only observe the ground under clear sky conditions. So lakes in areas with a lot of cloud cover have lower visibility. Conversely, some areas are blessed by more sunshine, so Hawke's Bay, Marlborough and Central Otago, for example, are favored by vineyards, not by accident. So, and the purpose of this analysis is that these maps can be used by regional authorities to immediately estimate the yield of data if it decides to invest into remote sensing technology. The second dataset shows the color of all New Zealand lakes, which was calculated by combining data from the blue, green and red spectral bands on the satellite sensor. Again, this data is based on the Landsat 8 satellite and represents an average over all observations from 2013 to 2016. Water color is important because it is the basis for deriving water quality constituents, such as the concentrations of chlorophyll, suspended sediments and colored dissolved organic substances. In general, clear and pristine water is blue, phytoplankton-dominant water is green, and water with a lot of suspended sediments and humic substances may be anywhere from green to brown. This map shows that New Zealand lakes span a very wide range of water color, and while there are some regional patterns, there is also variability of color at all spatial scales. Some noteworthy patterns include a high density of yellow to red lakes in the central Waikato region, and in central Otago, a number of blue lakes in the Bay of Plenty Te Arawa Lakes region, and a surprising range of deep blue to bright red lakes just east along the Southern Alps region in the center of the South Island. This analysis is an important first step towards converting the optical signal into water quality constituents, and it illustrates the challenge of dealing with an incredible range of water types in New Zealand, in which all constituents which determine water color can vary independently of one another. The field sampling we have been undertaking is aimed at validating the measurements made by remote sensing satellites. So we have been using our hyperspectral radiometer to take essentially the same measurements that a satellite takes, but right at the water level so that there's no interfering atmosphere. This instrument consists of two light sensors, one looking upward at the sky, the other looking downward to capture the upwelling light through the water column. The picture on the right shows the deployment of this instrument in Lake Tarawera together with Joe Butterworth from the Bay of Plenty Regional Council, and the line graph next to it shows example spectra determined in 3 different lakes. While in the field, we're also collecting water quality measurements at the time of the satellite passover, such as chlorophyll, suspended sediment, the absorption by colored dissolved organic matter, and Secchi depth. So far, we've taken measurements at a number of lakes in the Waikato and the Bay of Plenty region, and we're working with other regional councils to visit their lakes. The movie on this slideshow shows the radiometer mounted on a remote-controlled sampling platform owned by the Waikato Regional Council. We've trialed this platform on a number of lakes, and it enables us to easily sample small water bodies which are hard to access by boat. We're very happy with the progress of this critical step in relation to its 3-year timeline. We've obtained an 18-year dataset of Landsat images covering all 3,800 New Zealand lakes. And this dataset has just under 200,000 points, so it represents the treasure trove for time series analysis and correlations of water quality parameters with other information, such as catchment land use and climate variables. And we have presented many aspects of this dataset both nationally and internationally. We are now talking to the Horizons and Southland Regional Councils to obtain their existing in situ data and take our own samples in their priority lakes. Towards the end of this year, we will begin the data analysis phase and evaluate the performance of existing algorithms for the retrieval of water quality parameters from space. We'll also be planning the installation of the radiometer at one of our high-frequency lake monitoring buoys. It's quite hard to schedule fieldwork to match satellite overpasses, clear skies, and staff availability. So having an instrument in the field for extended periods of time will greatly increase our data yield. This concludes the summary of critical step 1.2.2 of the MBIE funded program Enhancing the Health and Resilience of New Zealand Lakes. Wen and I are looking forward to continuing the remote sensing work, and please do not hesitate to get in touch with us if you have any questions or if you would like to get involved. Thank you for watching.